Hello and welcome everyone. So, can I get a confirmation if my voice is clearly audible or not? Hi Rishit. So, were you guys able to solve the question of problem of the day? It was pretty basic question, and I guess every one of you might have solved the question in one go, right? So, what about the audio quality and my video? Okay, thank you, Rishit. Okay, so we'll start this session soon enough. Just a minute. So basically, at the end of the session, I'll be announcing something, but let's discuss it right now. And I'll be also saying at the end of the session that from now onwards, as we know that the solution for the problem of the day are being discussed the next day, right? Yesterday's problem of the day is discussed today at 6 p.m. So from now onwards, we know that earlier we used to have the solution delivered on YouTube at 12 a.m. in the night, right? On exactly the same day. So today's problem of the day, starting from today, each and every problem of the day will be discussed at 12 a.m. The previous schedule, which we used to follow, will be followed. Like today's problem of the day solution will be given on that same particular day at 12 a.m. Okay, so we'll be having two problem of the day video. I mean the live session today. This is for yesterday's problem of the day, and for today's solution, a session will be taken by the mentor at 12 a.m. I hope it was clear to everyone. Can I get a plus one if this was clear to everyone? And do tell your friends that this is the updated timetable. Okay, was it clear? Can I get a quick plus one in the chat box and then we'll start the session? And what about today's problem of the day? Were you able to solve today's problem of the day? Okay, thank you, Rishit, for the confirmation. I hope my screen is clearly visible. Okay, so basically, yesterday's problem of the day, that is 28th May, and the name of the question was nth node from the end of the linked list. Okay, the problem is pretty standard problem. Okay, if you have started learning, what say, if you are into linked list, right? If you have covered all the standard questions on linked list, then you might have encountered this question, right? So it's a very basic and standard question, and if you are not aware about how to approach this question, then you'll get a better understanding from this video. Okay, so let's first of all read down the problem statement. Given a linked list containing L number of nodes and given a number. So what you have to do, the task is to find the nth node from the end of the linked list. Okay, so let's take a look at the expected time and space complexity. The time complexity expected is linear order of n, and the space complexity is order of 1. And the constraint says that the length of the linked list can be as long as 10 to the power 6, and it can contain only a single node as well. And the value of n is not dependent upon the length of the linked list. Okay, over here it is not having any kind of inequality with the length. Okay, so from this you can get an idea that n can be greater than the length of the linked list as well. And these are the constraints. So let's first of all understand with the help of the test case. Okay, so just let me write down. Okay, so basically let's take an example, and let's say if linked list given to us was, let's say, 9. Okay, so there were 9 number of nodes: 1 2 3 4 5 6 7 8 and 9. Okay, so the length of the linked list is 9, and what you have to do, the value of n given to you is equal to 2. So this is my first test case, input number 1, the same which is given to us in the question, right? So I need to find out the second node from the end. Okay, so from the end means this side, and second node from the end is this one. So in the output, you simply have to write down the logic in the function. Okay, so you have to complete the logic and write down in the function, and the return type of that function, if we have a look over here, we can observe that the return type is an integer, so you have to return the value of that node. Okay, so you have to return the value, not the entire node. And one more thing, as I mentioned while taking a look at the constraint, so for this the output is going to be 8, and let's check it, and we can observe the output for this first test case is 8. So what I was telling that, let's say while observing the constraint, we came to know that the value of n can be in this range, right? And the value of L can be in this range. L is the length of the linked list. Okay, so there is no inequality given that in the test case, you are not said that every time the value of n is going to be lesser than or equal to L. So this condition is not given to you. So whenever, let's say, the value of n is greater than L, that means that in this question itself, let's say if I change the question, the length remains as it is. We know that the length of this linked list is equal to 9, right? And now let's say n given to you was equal to 10. So what does it mean? You have to find out the 10th node from the end, but the length of the linked list is not lesser than the value of n. N value is greater than the length of the linked list. So in that case, you simply have to return -1. So the output for this test case is -1. I hope this is clear to everyone that what we have to do in this kind of cases. Okay, so in this kind of cases, the output will be -1. I hope everyone was able to understand the problem statement. If you have any doubt, do write down in the chat box. So I want everyone to answer. Like, I want the answer from the audience that what can be the approach? What do you guys think? How can I approach in a brute force manner, or any of the approach which you think is a better one? So what can be the solution? How I can achieve it? It's pretty simple. Hello, Ronak. Hello. So basically, I need to find out the nth node from the end. Okay. So basically, what I can do, if you are told that you have to find out nth node from the end, then what you will be doing? You will be simply counting. Let's say if you are asked the question that find out the nth node from the front side or from the head node. So basically, you will simply count that this is my first node, this is my second node, and let's say this is my nth node. Okay, you are asked to find out the third node from the first or the left hand side. Then you will simply iterate, and while iterating, you will keep a counter variable. Now in this case, you cannot iterate in a reverse order, right? In a linked list, it is not present. It is not possible in a singly linked list because you don't have the previous pointer. If it was a doubly linked list, then you might have figured out some way to iterate in a reverse manner. So in this case, if I focus on the nth node, let's say the value of L is equal to 9 and the value of n is equal to 2. So now I need to find the second node from the end. So basically, let's identify what is the position from the front end. What is the position of nth node from the front end? Okay, so this is my node which I'm looking for. This is my node, right? And let me erase this. So basically, this node is present at the 8th position from the front end, and it is present at the second position from the rear end, right? Hello, Adini. Hello. Okay, you can rewatch the video because it will take too much of time if I repeat the question. So basically, in this question, we need to find out that nth node from the end. Okay, so n will be given to you, and I need to find the second node from the end. So basically, if I observe this eighth, this is the second node from the end, and from the front, its position is equal to 8. So basically, if I want to find the position of the particular node from the front end, if I'm able to identify that if this is the position from the front end, then the question is pretty simple. I need a counter variable, and I can keep on iterating, and until and unless my counter reaches to some breaking point, I'll be stopping and declaring that this is my nth node from the end. So basically, if I subtract the length and the value of n, so let's say I want to find the value of k. This k denotes the position from the front end. K is nothing but, let's say, L minus n. L minus n is length minus the nth position. So that would be 9 minus 2. So this gives us something like 1. So what do you think? What is this? Is it okay? No, I don't think so. So basically, I need the position. How can I find the position of the node from the front end? Can anyone from the audience say? Can anyone from the audience? I need to find the position from the front end. 9 minus 2 will give you 7, right? So basically I'm getting 7, but the position is 8. So what I'll be doing, I'll be simply adding plus 1. So basically, let's say if I'm keeping the value of k equal to 7, 9 minus 2 will give you 7. Can we solve this question with the help of a fast and slow pointer? No, you cannot solve it using fast and slow pointer. It is a completely different, there are completely different scenarios when you can use fast and slow pointer. Okay, so this scenario does not fit in that category. So basically I got the value equal to 7. So what I'll be doing, if you observe carefully, let's count the number of pointers. This is first pointer, this is second, third, fourth, fifth, sixth, and seventh. So basically if I jump 7 times, that is k number of times from the front end, I will reach the nth node from the end. So let's take one more example to get a clear understanding. I'll be using the same linked list. Let's say if this is my linked list, and what I need to do, I need to find out the value of n given to me was, let's suppose, I'm discussing the basic approach. Okay, so value of n given to me was equal, let's say it was equal to 4. So now over here I need to find out that from the front end what is the position of this node. Okay, from the rear end I know first, second, and third, and fourth. This is my node, I need to return this node. So the output comes out to be 6 in this case. So let's subtract the length. I know that the length of this linked list is equal to 9. And what is the value of n? N is equal to 4. 9 minus 4 will give you 5. So if I jump 5 number of times from the front end, 1, 2, 3, 4. This is 4. 1, 2, 3, 4, and 5. If I jump 5 number of times, that is k number of times from the front end, I'll be able to reach the nth node from the end. Was it clear? Was this idea clear? Yes or no in the chat box? Over here, while working with the pointers and the linked list, over here, you are going to use the counter variable, right? You need to count the nodes, and simultaneously you will be having some, let's say, pointer pointing to the node of the linked list. In that case, you simply need to focus on this link. Okay, so if this both are working together in your algorithm, you need to focus on this link between the nodes. Okay, you need to count the number of links. So k is the number of links. After this many links, you will reach the nth node from the end. So that is the entire idea. Okay, it was clear to everyone. So now let's handle the case when, let's see some of the corner test cases. Okay, so let me erase this example. And we know the formula for finding the value of k. K is nothing but L minus n. It's pretty clear, right? L is the length, n is the position. Now let's say L is equal to 9. That is the length of this linked list. And let's say n is equal to 9. I need to find the nth node from the end. So basically that is going to be the first node of this linked list, right? 1, 2, 3 in reverse order. It will end up at the first node of the linked list, or the head node. So now in this case, if you find the value of k, k will be 9 minus 9 will be equal to 0. Okay, sometimes you will be getting the value of k greater than 0. So in that case, you need to count the number of links skipped. But over here, when the value of k is equal to 0, you can simply return the head node. Simply return the head node. Okay, so that was one of the corner test case which we need to handle. Let's see one more corner test case. Now let's say the value of n was greater than L. Let's say it was 13. So for this, we are clear that the answer is not at all possible, right? So how will I be able to figure out whether the answer is not possible? Whenever I solve this equation, that is L minus n, that is 9 minus 13, that will be equivalent to something 4, right? It is equivalent to 4. So I get minus 4 over here. So over here, whenever you get the value of k negative, then that means the answer is not possible. In that case, return minus 1. So basically, if k value is lesser than 0, then you have to return minus 1. If the value of k is equal to 0, then your answer is what? It is equal to the head node. And what about the value of k greater than 0? Then I already explained, you need the counter variable and you need the pointer for traversing the linked list. Okay, thank you. If it was clear, Banita. So this is the first approach which I can think of. So basically, if I want to find out the time and space complexity of this approach, so what will be the time and space complexity? Let's analyze. Till now, was it clear to everyone? If you have any doubt, do write down in the chat box right now. So let's understand what can be the time complexity. So basically, first of all, I need the equation. I'm writing down the steps of this algorithm. Okay, so the first thing in this algorithm is to find the value of k. K is equal to length minus n. So basically in the question we are simply given a function, and the function will be having two arguments. If you observe over here, the function has only two arguments. One is the head node and the position of the nth node, right? So basically we are not given the length of the linked list. So now, although in the input test case you are given the length, now if you are not given the length in the argument, you need to find out what is the length. So now in order to find the length, you need one more step, that is calculating the length of the linked list. So the optimized approach will be a variation of this thing. Okay, so we need a better understanding of this approach to understand the optimal approach. Okay, so calculate the length of the linked list, and that will be stored in a variable called as L. Now I can calculate the value of k. K is nothing but L minus n. Okay, and now I need to simply focus on the value of k. If k is negative, then I can simply like, let's say, declare that answer is not possible, right? And now if the value of k is equal to 0, so what does it mean? The head node is my answer. Okay, and what about the value of k greater than 0? In that case, I need a counter variable. So let's say, what is the counter variable? This is my counter variable. Okay, so if my k value is reduced down to 0, then that means I have reached the nth node from the end. So basically, what was our task? Our task was to find the nth node, and let's say n was equal to, let's say, 4, and we calculated n minus L minus n. What will be the value in this case? It will be equivalent to 5. So what I'll be doing, I got the value of k is equal to 5. So now I will be having a temporary pointer pointing to the head node, and my k is equal to 5. So now what I'll be doing, I'll be moving my temp one position forward. Okay, I moved my temp one position forward and simultaneously decrease the value of k. Now k will be equivalent to 4. Again, move the value of temp forward. Now it is pointing to 3. The k value will be reduced down to 3. Now again, move the temp variable forward. Okay, so now k value will be reduced down to 2, and now again move the k value forward. Now on moving, it has encountered what? It has encountered this node, and now reduce the value of k to 1. Now move the pointer forward, and now on moving the pointer forward, when you move the pointer forward, the k will be reduced down to 0. And this is when the value of k is reduced down to 0, then that means you have reached the target node. So this is the output for n is equal to 4. You can verify 1, 2, 3, and 4, and you have to print 6 in the output. So basically, you can reduce down the value of k to 0, and when the value of k on whichever node the value of k is reduced down to 0, that is your targeted node. So basically, over here, if the value of k is greater than 0, I can add in this manner, while k is greater than 0. And what else? If my temp is not equal to null, temp will be the temporary pointer, right? If this is not the case, then what I'll be doing, I'll be moving my temporary pointer forward. Temp is equal to temp dot next, and I'll be decreasing the value of k. Temp will be initially pointing to the head node. And let's say, what will be the time and space complexity of this approach? Let's discuss. So basically, just a minute. So basically, let's figure out what will be the time complexity. In order to calculate the length, I need an iteration that will be order of n. This is constant, this is constant, this is constant, and this, what about this? I need to iterate, right? In worst case, it is possible that the iteration is over the entire linked list. So in worst case, this iteration will take order of n. Now, what about the space? Have you used anything depending upon the size of the test case? Nothing has been used, right? So the time complexity comes out to be order of n plus n, that is order of 2n, that is 2 iterations are required. Okay, got it. And now what about the space complexity? Space is not required, so space complexity comes out to be order of 1. So this is already equivalent to what is required in the what is required by the quotient. But over here I'm using 2 iteration. Can I do it in a single iteration? Yes, you can absolutely do in a single iteration. So let's see how you can do in a single iteration. Okay, so now let's do it in a single iteration. So basically, in order to do it in a single iteration, what I need to do, what I'll be doing, I'll be using two different pointers. Okay, not slow and fast pointer, completely different pointer. So first of all, I will be using my first pointer. My first pointer will be pointing to the head node. Now this is one of the iteration. Okay, though in the first iteration, I'll be having my let's say first iteration. It is the first pointer and the second pointer. Okay, so the first pointer is currently pointing to head node, and I'll move my first pointer n number of times. Okay, so n number of times means 4 number of times. This is 1, this is 2, 3, and 4. Okay, basically I need to move n number of times. So it was over here. This is 1, this is 2, this is 3, and this is 4. I moved my first pointer n number of times. And now I'll be needing a second pointer, and this is my second pointer. Now simultaneously move both the first and the second pointer. If you move both the first and second pointer, let me use something like this. So now first and second pointer will move simultaneously. So whenever the first pointer points to null, your slow pointer or the second pointer will be pointing to the nth node. So let's start moving forward. 1, and then move forward again, and then move forward again, and then move forward again. And now you can observe, moving on forward, this points to null. If this points to null, over here your second pointer will be pointing to your nth node. So now over here, if you observe carefully, I was not required to iterate 2 times, right? A single iteration, every node was encountered only once in this iteration, or in this algorithm, right? So basically you need first and second pointer, move the first pointer n number of times, and now the second pointer will be starting from head. Now simultaneously move first and second pointer together until and unless your second pointer or the first pointer is pointing to a null node. Okay, so in this manner I can do it in a order of n or a single iteration. So if I write down the algorithm for the same, if you have any doubt in this approach, then do mention it. So now there are some corner test cases which I need to handle. Uh, let's say the value of L, let's say the value of n was equal to 9. Okay, so now you will be moving your first pointer n number of times. Let's say this is my first pointer. N number of times means 9 number of times. This is 1, this is 2, 3, 4, 5, 6, 7, 8, and 9. On moving the first pointer 9 number of times, you can observe the first pointer is already pointing to the null node. Over here, I have not introduced my second pointer, but before the second pointer was introduced, my first pointer is already null. Actually, I am Matbar Joshi. I joined with my sister ID. Okay, Matbar, got it. So basically, the first pointer is already pointing to null. So now in this case, can I directly declare that the answer is my head node? Is it okay to do that? Like, will that work? If my first pointer is directly pointing to null, I can absolutely declare that this is my the head node is going to be my nth node. No, you cannot do that. Why? Let's understand. So basically, I was able to figure out a condition that if my first is equal to null, then for this quotient, for this test case, the output came out to be my head node. Okay, so is this condition like enough for every test case? No, it is not enough. Why? Let's see. Let's say if the value of n given to you was 10. Now we know that L is not given to us. The length of the linked list is not given to us. So now if this is the case and my first pointer was over here, what I'll be doing? I'll be moving n number of times. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. I was not able to move my first pointer n number of times. And before moving the first pointer n number of times, my first pointer is already pointing to a null node. I cannot move forward. So basically, I came to know that I have not like moved my first pointer n number of times. The position, I mean, I was able to only move the first pointer 9 number of times. That is lesser than actual number of times. So basically, you cannot directly say that if my first pointer is pointing to null, then I can directly return the head pointer because head pointer is my answer. No. Whenever your first pointer is null, and if the value of n, I will be utilizing the value of n. If my n is equal to 0 and my first pointer is also equal to 0, I mean, if my n is equal to 0, if my n is reduced down to 0, that means n number of times first pointer was moved forward, and my n value is being reduced down to 0, then and only then I can say, if this is the case, then and only then my head pointer is my output. Okay, if the first is already null and your value of n is greater than 0, okay, in this case the output is not possible. In this case the output comes out to be -1. In this case, this is my first condition, second condition, and in the third condition you already know what you need to do. You need to introduce your second pointer. Second pointer will be pointing to the head node, and I'll be iterating both the pointers. I'll be moving both the pointers together. So if my first pointer is not equal to null, I will keep on moving first and second pointer simultaneously. So second will be equal to second dot next, and your first will be equal to first dot next. Okay, and at the end, after completion of this iteration, you can simply return the value of the node pointed by your second pointer. Okay, so this is the way in which you can solve this entire question in a single iteration. Was it clear? Okay, so let's write down the solution for this. So now here is the solution part. First of all, I'll be writing down the steps as well. So the first step was to move the first pointer n times. Okay, so I'll be needing a first pointer while n is greater than 0, and I need to put this condition because the value of n can be greater than the length of the linked list, right? And if my first is not equal to null, okay, both the conditions are important. So I'll be moving my first forward and value of n will be reduced. So now after this, I have one condition to check, that whether the answer is possible or not. If the answer is not possible, then what was the condition? Over here, if you take a look, if the first is null and the value of n is still greater than 0, then answer is not possible. If the first pointer is pointing to null and the value of n is greater than 0, then what does it mean? You simply need to return, in this case, return -1. Now, what about the second condition in which the answer is a head pointer? Can you include both this condition together? Yes, you can include. If your second is pointing to head node and your first is already null, then your second will be directly be returned, right? So the second condition, I'll be handling it inside the loop only. Okay, so now I need to introduce. Okay, so second pointer node second is equal to head. Now I need to move both the pointers together. First is not equal to null, then I will keep on moving the first pointer and second pointer together. Okay, and at the end, if whatever is the data of the node pointed by second is my output. So now let's try to compile and run. Okay, so this is working fine, completely fine, but let's insert some of the corner test cases like this one. It is also working perfectly fine. Let's include one more test case. Let's say it was 10. Now in this case, -1 should be returned. Okay, it's working perfectly fine. Let's try to submit. And the problem was successfully submitted. Okay, so the time complexity of this approach is linear, absolutely linear. No more than one iterations are required. And what about the space complexity? Space complexity is also constant. Let me share the solution in the comment section as well. Any doubt till now? Okay, so basically I was saying that the timings of the timings of the POTD have changed. Earlier, we were having the live session on POTD at 12 a.m., the exact same day on which you had your problem of the day, right? So, from now onwards, from today's problem of the day, you will be having the solution or the live session exactly at 12 a.m. Okay, so the previous session schedule will be continued. So, basically, on that particular day, is there any update in timing of POTD? Yes. So I was discussing that only. On that exactly same day, let's say today's problem of the day solution will be discussed at 12 a.m. The previous session, like in earlier also we used to have this same thing, no? We used to give the live session on the same day at 12 a.m. So from now onwards, we'll be having the live session at 12 a.m. Okay, regarding the problem of the day. So today's problem of the day solution will be taken by the mentor at 12 a.m. Okay, so do share this information with your friends as well if they are also doing problem of the day. So apart from that, any kind of confusion or anything, any doubt? Okay, I see no doubts coming, so I think we can end this session. Okay, thank you. Okay, so that was it for today's session, and I hope everyone is able to solve the upcoming problem of the day. Thank you, everyone. Thank you.